Hello, everyone, and thank you for joining us. Today's webinar, GenAI Network Autonomy or Network Automation, sponsored by VIAVI Solutions. Our speakers today are Anbu Ganesh, Director of Innovation and Business Development at VIAVI Solutions, Monica Paolini, Principal at Sensafili, and we also have Taqiyuddin Kanush, the CTO office at VIAVI Solutions, who works closely with Ambu and is behind the scenes today to be available to answer some of your audience questions during the presentation. And I'm Kendra Chamberlain, and I will be moderating our webinar today. We would like to encourage our audience to participate in the conversation. So please share your comments and questions using the chat and Q&A functions on the Zoom taskbar. All comments are visible to all participants, so please keep the conversation polite and respectful. We encourage you to ask a question at any point during the presentation, but there will be a Q&A session at the very end. And with that, I will hand it over to Monica.
Kendra, thank you so much for the introduction, and thanks for VIAVI Solutions for sponsoring this this conversation today, which is, I would say, extremely timely. Not only timely, but it's really, I would say, it's the hottest topic that we have right now, and I expect to see a lot of discussion on GenAI at the Mobile World Congress in a couple of weeks. And I think that there are two reasons for why it is such a hot topic. And they are kind of illustrated in this two graphs that I'm showing here. There is clearly a lot of interest in GenAI, and some of it is hype. So there is a camp that sees, everything is possible, and then there is some pushback at the same time, because is it really true? So that you can see here, this is after the metaverse, GenAI is the highest hyped technology according to operators, according to this telecoms.com survey. And then third one is actually AI. But then at the same time, you can see that AI and machine learning are the areas that are the priority investment areas. So the question is that why is it? Is there a disconnect? And I think that the reason is that there is a lot of, I would say, confusion. There is lack of clarity into what is the opportunity, what are the concerns, and so the question is that how can we actually get GenAI and more generally AI and machine learning work to help us and to avoid the risks and concerns that we have, which is why the webinar today is going to be really addressing those issues. So we're not going to talk generalities today. We're going to go and talk about what is that GenAI can do for us, and how can we avoid risks. And so we're going to have a reality today, no hype, I promise you. And I am sure that Ambo will do that. And so I'm going to hand it over to him, and make sure, as always, that you ask questions or even write comments as we go through. So Ambo, over to you.
Thank you, Monica. Let me share my screen. Hello, everyone. So the topic today, network autonomy or network automation. So this is going to be the agenda where we are going to look at the definition of automation versus autonomy, GenAI, why it is popular, as Monica pointed out. Then we are going to look at telco-specific GenAI and how autonomy is possible, and how do we prepare our network for autonomy. So some definition, the basic definition. Automation is performed without human intervention, but humans are in the loop. Autonomy is you don't need a human in the whole loop. It gets taken care of by itself. Let's say automated car parking and also driverless cars. So AI plays a very important role in both automation as well as autonomous networks. So problem definition becomes very, very pivotal when it comes to AI system, whether it is GenAI or the predictive AI. Let's call the existing AI as predictive AI and the GenAI as the GenAI so that the audience doesn't get confused on the terminologies. So the famous saying, right? If I were given 1 hour to save the planet, I would spend 59 minutes defining the problem, 1 minute resolving it. Albert Einstein's famous quote, right? So it all boils down to defining the statement of the problem and the corresponding next best action. So at the end of the day, the models are supposed to take care of this. And multimodal approach, where you are feeding in a variety of data, whether it's probe or CNF logs or even your network element logs, streaming, curated data, etc. This is going to help in the multi-domain correlation as well. Another important point is the digital twin. They have to curate the digital twin in the form of a lab where you can apply these models onto this digital twin. There are operators who are having digital twins in, let's say, domain-specific digital twin, end-to-end digital twin. Let's say your transport layer, a copy of your transport layer is in your lab, where a combination of synthetic data as well as real-world data is fed into those, and then the models are applied. So now moving on to this levels of autonomous network defined by TM Forum, you will see L0 to L5, where L5 is completely autonomous. From our discussions, we see that operators are now moving from L2 to L3, and some of them have aspirations to reach the L4 very soon. So the key point here is, even though humans are in the loop, the systems are providing the insights, next best action insights, so that humans are actually doing the task that are advised by the systems. The second one is the controlled automation, where the next best action is presented in the form of a script or even in the form of a command configuration change. The human, the network responsible person who's sitting in the NOC or attending escalation would execute the command after verifying. The third one is completely out of the loop, where there is a closed loop model where the system is looking at the past events. It also has the knowledge and intelligence to execute the remediation steps. So now we talk about the predictive AI, the AI that we are currently applying in our daily lives in the networks. Some of the use cases here are anomaly detection, what-if scenario, noise reduction and deduplication, capacity forecasting, and incident classification, right? We are also using to compress the number of alarms. You're able to do a parent-child correlation and then clearly isolate the incidents and then take the next best action, or the remediation loop gets executed. We also hear a lot about hyperautomation use cases. Hyperautomation is nothing but your AI plus your workflow. You know, the robotic process automation, the workflows, so they combine with the AI. So now here we have a classic AI ops platform where pipeline, you know, the AI pipeline, AI ML pipeline, where we collect varied amount of data. On the left-hand side, you can see right from events, alarms, metric logs, up to the probes. the network is becoming complex, right? We have, let's say, your traditional network, and also you have the cloud aspect, IT aspect coming in. So we have to have a robust mechanism to collect all these logs and correlate them in an efficient way, because there's going to be a lot of noise when you are doing a even compression, right? Say, for example, if there is a pod that is getting crashed, so we have to also go beyond the pod and then look at whether it's a issue with the let's say Kubernetes networking, or even there is a genuine CPU spike, or even if there is a problem in the CNF itself, the container that's inside the pod. So we have to do a lot of classification and feed these intelligence into the model, right? And then finally comes the closed loop action. So some of the famous algorithms that we are applying, the time series as well as the LSTM, ARIMA, auto ARIMA, XGBoost, etc. Those are being applied, and we are getting very good results, and the RCAs are becoming more and more helpful. And we tend to start gaining trust. We have started gaining trust over these algorithms, especially from our experience recommending the next best action, or even, for example, your what if scenario. Somebody, let's say there is a promo, free data pack is about to be rolled out by the marketing campaign team. They want to know, what if so much of data is going to hit this particular CBD area at this and this time, between this and this time. So we are able to run these models effectively, and we are able to see the choking points or the congestion points. That becomes clearer. Again, I'm also seeking the digital twin here. You need to have a robust digital twin if you don't have one in your network. So that helps us preparing ourselves for the GenAI. So GenAI, it's not a new concept. We all know about this Google Translate, or even the email autocomplete, or even when you're typing a message, even a WhatsApp message, there is always this recommendation, autocomplete recommendation. Well, ChatGPT has changed everything. But however, ChatGPT is limited by the model, right? If you ask ChatGPT to disobey, it cannot, as in it will never understand what is disobeying. So it is programmed to execute certain steps, and that's what it is going to do. And looking at the amount of parameters, let's say several billions of parameters are fed into the intelligence here. And it also holds the record for the fastest, 100 million active users, whereas, what Google took about 78 months, ChatGPT was able to do it in 2 months. And please note, it all comes with costs, right? They have these massive amount of resources. They are throwing GPUs on these, running these systems, especially it goes like one Google query is equal to 100 times, the energy for ChatGPT. So the focus at the end of the day is on NLP task. Well, there are these concerns, as I was mentioning, right? If you go and ask ChatGPT some of these questions, most of it are very useful. However, some of it are very, very wrong. So I was thinking, are they trying to mimic the human brain? Well, what they are doing is, let's say a poor performing student, instead of teaching them, they are also throwing a lot of GPU power onto it. Instead of 1 plus 1, they hard code 1 plus 1. They have got so much resources so that they can even do a hard coding instead of a compute, because that's the level I was thinking. But however, everything, whether it's creativity, because it's generative, is all about combining multi-modal data and then generating new content, right? It's all limited within the framework because the models are performed to do set of actions within the framework. But if you, let's say, ask the ChatGPT to produce a Gödel's theorem, the famous, the arithmetic theorem, right? The Gödel's theorem, it cannot, because Gödel's theorem involves going outside the system, explaining it. So which means it cannot do it at all. So these are the limitations. But if you take autonomous driving cars, we have been hearing about, they are trying their best, but this neural networks that are applied, it is continuously improving, but we are not there yet. Privacy and security is a concern. Shadow AI and poisoning, this is going to be a big concern. I'll be talking about the governance as well. How do we handle this? But what happens is somebody gives a wrong configuration, somebody pushes the wrong configuration, somebody poisons the model by feeding wrong parameters. So those are going to be some of the challenges which results in hallucinations, right? As I was mentioning, ChatGPT asked some questions and they give wrong answers, right? So the worst case scenario would be it causes network outage, and trust is going to be an issue. And usage of proprietary data is a concern. Again, governance needs to be taking care of that. Where it all started, right? We were in this predictive AI world where we were pushing. If you look at the good old days, we were looking at the time series algorithms. We then moved to ARIMA, auto ARIMA, XGBoost gave some help, and then KNN helped us. LSTM is very good as well. But however, the concept here is all about how much of memory I can hold. For example, if you throw a paragraph to the ChatGPT system, it's able to go through the complete paragraph, understand, and then it's able to respond. So what they have done, researchers from Google as well as University of Toronto, what they have done is they have come up with a what do you call encoding decoding system with this backward propagation, etc., and which is able to hold a longer memory, large sets of memory, right? LSTM falls short in the memory, whereas this one has a long memory and large memory. And that is what they call it as attention heads. That's why this famous paper that was released in 2017, that's the beginning of everything. That's what we have. And look at the language models right now we have. BART is there, and GPT-4, 1.5 trillion parameters. And interestingly, instead of making use of the API or even the open source, Bloom just open sources the language models, the large language models, or even GPT-4, you can use the API, make use of the foundation model, the language model that, the pre-trained model is called as foundation model, right? Some enterprises, for example, Bloomberg, they started, 50 billion parameter LLMs. They decided that I want to do a finance specific, let's say finance specific LLM they are building. Similarly, there is a probability that telco specific LLM could be there, or even with the existing pre-trained model, we can also do some fine tuning. We'll talk about those fine tuning the LLM, and also how do you create your custom models, etc., in the coming slide. But where can we apply network optimization even in configuration changes, pushing the configuration changes, the right set of solutions, because you're going to have large repository of your trouble ticket and probable solutions, or even the remediation steps, right? So somebody has to go learn all these and then provide the right solution, understanding the context, right? The beauty of this large language model is that you're feeding the context to this particular language model. That is done through RAG ops, your retrieval augmentation operations, right? So those are some of these things, and definitely marketing can do a lot of promo, and fraud detection is another use case. And overall customer user experience can also be improved using GenAI use cases. So phases of GenAI, this is again from TM Forum. They have defined the phases of GenAI for telco. And as you can see, this was from last year, 2023. In the next 2 years, what they expect is, if you look at the operations domain, service management, digital twin, all these codecs, text to code for application. Well, talking about code, if you look at the software industry, that's rapidly making use of this GenAI Copilot. Productivity doubles or even triples, I should say. But Copilot is very, very helpful, and developers are now looking at some of these strategic actions rather than writing these, the usual routines or the standard routines. Copilot takes care of it. So if you draw a parallel between the software industry and network operation telco, we should be embracing GenAI because it is going to be helping us. But however, coming back to this particular slide, for example, digital twin, it is going to have both our old predictive AI. When I say old, whatever I mentioned a few slides earlier, it's a combination of your predictive AI and GenAI. It is also important at this point, I would like to point out, it is very important for us to have a very robust ML ops so that we can move to LLM ops in a more seamless way. Asset management in automation or even network autonomy, asset management plays a very vital role, having a robust inventory for your cloud, for your, the network. It's very, very important. For example, VIAVI has a very state-of-the-art network inventory that caters or that enables the network automation and autonomy. And on the long term, they are also talking about strategic decision making and the supply chain automation as well. Let me move to the LLM ops for the telcos. So we have the pre-trained model. Let's say that you are taking it from Llama, from Meta, or even ChatGPT from OpenAI. Let's say that this is on the left-hand side, you are bringing that model. That's also known as the foundation model. What you do is you bring your private data, that is your network data, using, there are two methods to fine-tune, right? RAG is a very well-known, and you might be hearing RAG ops as well, apart from your LLM ops. So we use this, and then we create a RAG ops, and we create a custom model where you can then start, the prompts, user prompts, the queries, the questions, right? There is a separate vertical called as prompt engineering. So you're going to hear prompt engineering user prompts, all these are going to be, the everyday life you're going to be hearing, just like your LSTM or ARIMA, auto ARIMA, the data scientist keeps bombarding us, right? So your prompt engineers are going to train these LLMs. The model will get fine-tuned. And I'm going back to the digital twin and a lab that hosts all these digital twin. Prompt engineers are going to take care of this, curate in such a way that it aligns with the real world. So governance is governance is a very important topic, right? So recently there was in France there was this conference where a lot of emphasis was given on governance, and somebody like CAIO, Chief AI Officer, needs to ensure the governance. Let's say what prompt response, right? Response for prompt needs to be regulated, validated, and then it has to be deployed onto the network. Right? So we have now been looking at let's say, a different team structure. Right now, we have this NOC, you have your planning department, and also you have this, what do you call them, the IT department, right? So it is all converging now. If you take the current network, your IT and network are together. There are these CTIO roles that are also coming into picture now, but CAIO will have his or her own, the LLM head, and also the ML ops head, LLM ops head, and also the prompt engineering is going to be a division under him or her, so that the prompt engineering, which continuously trains these model, the model tuning takes place. It is also important to take care of our knowledge database, right? Knowledge base. So knowledge base, you curate the data, you bring in all your trouble tickets, you bring in all your logs, logs, metrics, etc. And then you start tuning the model on top of it. And then before I move into the summary aspect, I wanted to point out a few things. With respect to your database, graph database is taking over, as in you have to have a strategy for having a robust graph database, because that is going to define your relationships, and that plays a very big role in terms of updating the context. Right? If you recollect your chat GPT or even the GenAI story, it all boils down to this context, right? How do you give the context, or even the the transformers that I was pointing out, the attention heads? You have to have a very good graph database to have these defined. And feeding the data, what data we feed, is also very critical, right? So your existing data science team, right? Let's say they collect the data, they cleanse the data, remove all the noise. That's very, very important, even in your LLM ops. So whether you're fine-tuning your GenAI, that's very important. So as I was pointing out, predictive AI and ML ops needs to be streamlined. You need to have focus on the fundamentals, have these pipelines clearly defined, and it has to go beyond a single domain. What mistake most of the operators are doing is they are having a very solid radio. I'm taking an example of one particular operator. They are focusing heavily on the radio. However, what happened is the transport, the IP, as well as the fiber DWDM, that's not taken care. So they are now focusing on the layers that are beneath the radio. So it is very important to have a multi-domain strategy and multi-domain modeling in place, again, in the digital twin form, because you cannot straight away shoot to the network, where L1 activities needs to be automated, completely automated. And part of the L2 activities that needs to be taken care as well. How do you take care of these L1? Well, knowledge base is going to be very critical for you. Again, a very robust graph database has to be in place. What trouble ticket? Let's say you create a trouble ticket. You look at a problem, create a trouble ticket, and then you also look from the knowledge base what kind of solutions have been provided by the vendor or even by another department. You start executing those remediation steps. And also, when it comes to L2, very complex multi-domain correlation, you have to look at more than one knowledge database because different departments are feeding into those database. You have to have a multi-domain database as well. So that needs to be automated. Again, both LLM ops as well as ML ops is going to help you on that. But please remember, automation will lead you to autonomy. A robust workflow, right? Low-code, no-code platform where you are able to execute, you're able to talk to the node and then start monitoring. A closed loop action is very, very critical. And as I was pointing out, we have to build the trust, right? So if you do not trust the system, let's say you have set of your LLM ops, ML ops, data scientists, they come to you, and then you don't trust the system at all. So all the effort, is futile. So we have to ensure the model is fine-tuned and it is also robust enough to handle any adversity, and you have to protect it from poisoning, shadow AI. Somebody should not randomly throw some parameters, the set of parameters, right? And please note that talking about parameters, I want to also point out, please note that there are these 16 layers. It goes through 16 layers of encoding, decoding, right? When we want to fine-tune our models, we have to go beyond the obvious, let's say, our typical ML ops. What we do is we fine-tune this, let's take LSTM model, and then we wait for the feedback, etc. So there's this layers that differentiate in your GenAI concepts here. So adding more layers will help you making your models more robust. And finally, I think I've overemphasized this digital twin because because it's not so easy to get the network snapshot, right? And configuration changes are always a challenge, right? Somebody shoots a wrong configuration, and we have heard about this famous outage very recently. A few months ago, there was one massive outage where the operator has to pay penalty, etc. It was a small configuration change, but it had a domino effect in the network. So it is also important when you do a patch upgrade, you have to also look at the multi-domain scenario where you look at what is the the impact and then the response from it. then you take an action to do the network upgrade. Again, the point that I have with respect to GenAI is, please understand that you are not talking to a human. It is a glorified AI chatbot. Chatbot has become a little more intelligent. So we have to keep in mind and keep our guardrails to make sure that the model is fine-tuned when we execute any action to the network. And with respect to, for example, any new network element coming into the network, we can also bring the network topology. For example, take a new network element that is introduced, a new CNF being introduced. Network topology will also help you understand and then fine-tune the models eventually. And finally, if you look at the GenAI, which is along with the predictive AI, are enablers for functionalities like knock, which will pave way to autonomous networks, which is definitely a possibility here. And when we talk about knock, we are right now, once you automate your L1, L2, I think now we are pretty sure that nobody in the network is staring at those monitor where you're bombarded with tsunami of alarms, where somebody has to just acknowledge, yes, I have seen this alarm. I don't think that is happening now. Most of the operators have embraced some form of automation where A, trouble ticketing, B, next best action for those tickets by referring to the knowledge base. Those are already happening. And I would call it as a gray knock instead of a dark knock that is happening. And there is also some of the activities like they are introducing these bots in different domains, different regions. There is an operator where they have this, what do you call the pair knock engineer, where they have paired a chatbot, a bot along with an engineer, so that that provides the insight to this particular engineer. However, that also works on both your predictive AI as well as GenAI updates, and then feeds the output or feeds the outcome to this particular engineer. And that's basically what I have today. And I would be very glad to take the questions. Thanks.
Anbu, thank you so much. This was a very refreshing presentation because, you told us that I think we got all the idea that you're actually working on this. It's very hands-on, and oftentimes, especially when people talk about Gen AI, there is a lot of generality, but you don't get a sense that people are actually working on it. So that was very, as I said, very refreshing, but also a lot of information. And we have many questions from the audience, and I have a lot of questions too, obviously. But we will go with the audience first, with one exception. I just wanted to ask a little bit more about the dark knock and the gray knock that we learned about it today. Can you tell us a little bit about, I guess it's a very good example of the opportunities of AI. So maybe you can give us a little bit of a sort of the concrete sense of why are operators doing it, what really is, how it's going to change the way they do it, and how is it something that is realistic in the short term, or is the gray knock something that we will eventually get to the dark knock, but it's going to take quite some time?
Yeah, good question, Monica. So definitely right now there are forms of dark knock. However, trust is the question. So as I was pointing out, you have to bring a multi-dimensional, multimodal, concept here, where you correlate the data and then you train the model, then you get the next best action along with the remediation loop, right? So we have to test it out, and we have to make sure that the model is close to the real world solution. Once we vet and validate, then we can move from gray knock to dark knock. So which is again, your lab and your digital twin plays a big role there. And then you bring it to the real world. And then you mentioned that, okay, whenever I see such problems, go execute, look at my LLM large language model, or even look at some of the algorithms and then go do the remediation. Yeah.
Absolutely. And, and I guess that one thing that we learned today is that there are so many parts that you need to keep in your mind. I mean, as we think about the problem, as I said, the crucial part is to define the problem. So there's so many elements coming in, and there is so much of the existing knowledge and expertise that go into this. Now, let's get to some of the questions, the questions from the audience. The first questions that we have, and by the way, all of you in the audience, you still have time to get questions in. So the first question is from Pawan, and the question is, with network monitoring becoming automated and complex, how are you segregating false positives from actual alerts? Which I guess sort of goes back into, sort of related to the hallucination part to some extent, because it's, how do we know? If I have to check everything, then what's the value of automating or using AI?
Very good, right? So for example, it goes back into the very good question, but yeah. So this is what we often ask when we are told to execute, or how do you trust? So how much do you rate and all when they come and ask me? So this is the question I ask them. But the point is, we have to build the model over the period of time. You feed, as I was mentioning, it's a framework where we are feeding intelligence. We are making it more and more intelligent. Of course, you are going to be throwing more GPUs into it with different scenarios and the solution. Over the period of time, eventually you will get to a point where some of these scenarios, false positives, etc., those are going to be covered, and the next best action would also be coming out of the systems. The model takes care of it. So tuning the model, again, through either prompts, prompt engineering department has to take care of it, or even your LLM ops, they have to make sure that it's taken care of. Yeah.
Absolutely, and I guess it's it's kind of a gradual process. So you have to keep refining, you keep improving, and then eventually you go back to your issue that you're going to build trust, and you build trust like as with a human through interactions, and then eventually you'll get to a better place.
Yeah.
Okay. Now, next question is from Aditya. How can we include AI in predicting that handover or carrier aggregation is going to fail from current running logs and changing parameters and configurations accordingly?
Yeah. So, well, so if you look at these are I would say that these are it's a good question from the RAN activity point of view. These are taken care, again, if you look at, it's a combination of automation loops plus your model, right? So let us not get confused between simple, straightforward automation routine. If I see such, let's say, configuration, let's say a wrong handover configuration, if I'm getting a lot of handover failures, then look at the configurations. If there is a handover parameter, wrong configuration parameter, go fix it. Then you go back and check if it has improved, etc. So, defining the condition, feeding the models with all these the parameters, information, that is going to help us out in the long run. Again, feeding the parameters. So we are talking about different kind of parameters and the tokens, etc. I was mentioning, right? So the more you feed the scenarios, eventually you will have a robust model. That's the answer. I hope I have answered the question there.
Okay, and for all of you, if you have any follow-up questions, feel free to send them in, and if we don't have time, we'll get back to you afterwards.
Would be glad to support. And also, I want to bring something that I forgot to point out. There are these blogs. One of them is a very good blog from our CTO, The Transformative Power of Telco AI, that covers some of the topics that we discussed today as well. So I encourage the audience to have a look at these blogs as well.
Absolutely. And may I ask David to post the links to them, because I don't think that people can get to the links. Anyway, okay, so more questions. The question from Uday: how do you capture and route data from ML or to train ChatGPT type LLMs? Is there any standard recommended approach?
Yeah.
And I guess that I would also ask, what is the relevant data here? Because, we're talking about a very specific domain.
Yeah. So again, your LLMs, if you talk about LLMs, these are the NLP, right? Natural language processing, as they say. It is trained to auto-generate some of these sentences. That's the very primitive way. But however, generative AI has changed the way it can look at different layers and then come up with solutions. For example, hey, go and create a web page where I'm I'm interested in plants and I'm interested in gardening, etc. But I want this website. So it can just understand. It picks up the images. It picks up the right text. It then creates this web page. It writes the code, and here it is. So with respect to telco, either, as I was pointing out, either you can create your own LLM from scratch, which is going to be very expensive, super expensive. But however, I was just tossing this idea some time ago, but if all the vendors come together, telco vendors come together and create a language model, and if that caters to these operators, or other way around, if operators are creating an LLM, and then it caters to the large community, that would also be helpful. Either it can be a closed API exposing, or even open source telco LLM as well. But again, the specifics, let's say regional specific or seasonalities, needs to be also taken care, or else you would end up with poisoning as well. But coming back to this one, what you do is there's something called, I strongly encourage to look at RAG ops, where you embed the vectors, which means context, and then you pass it on to the LLM. So that's what is going to happen with respect to our telco data. You ingest the context through the logs, metrics, etc., onto this LLM, and then you get the the query. You then do the prompts, and then it delivers the solution. Yeah.
So basically, you reduce the space. You don't need that many inputs, and that basically helps you and makes it presumably more reliable in terms of, you sort of clean up your data, so to say. To some extent. I mean, if you use whatever it's available on the internet, you're bound to have a lot of noise.
Yeah.
If you use the data from a network, it's going to be less noisy.
Yeah. It's not cleanup per se, Monica, but you're almost right. But I would rather correlate and do a deduplication process. So this is called as deduplication, right? So if there is a fiber cut, you're going to get so many alarms. Having a graph database which holds the relationship, and then you have the context as well, then with the relationship and the context, relationship graph DB, which is again going to be from your inventory, saying that these are the network elements that are connected to this fiber, that is going to help you. So that immediately you will say that, hey, these alarms are coming from this path, and this is all originating because of this fiber cut. So immediately, in your words, like cleanup happens with 1 or 2 incidents. So that's the beauty here. Yeah.
Okay, so more questions from the audience. This is from William. And would GenAI allow increasing the number of open systems available for the public? For example, open 5G or other publicly accessible AI ML tools. So I guess that the question is, should the users care? Are they going to see any difference?
Yeah, well, definitely. But here is the thing, right? So you should not also get rogue, right? That's another biggest worry, or the threat is, what if somebody poisoned the whole model, right? But answering to William, yes, there is a possibility, but however, the governance body, HC, etc., they have to also certify and then make this thing available for the larger public to consume these. But there is a possibility. Yeah.
Okay, one more question from the audience, again from Pawan. With many cyber attacks increasing and they use innovative methods, how will GenAI assist on securing the enterprise network in security and governance areas? And I guess that's if I would say it's the enterprise, but also public networks, because GenAI can help people making attacks, but also can help you identify attacks. So it goes both ways, right?
Yeah, yeah. So this is definitely a very significant use case in terms of security. If there is any attack, or even man in the middle, or even some of these, you have these attack threat list. We constantly update the knowledge. So definitely this is going to be very helpful, especially in the GenAI, where you can go through the knowledge base. You will be able to see the logs, and then you will be able to see an unusual pattern, right? And that's where the trigger comes, where you come across an unusual pattern, and then you alert saying that, hey, this is something that is unusual. And then the next best action, the remediation, comes in, and then you block that particular port or do the remediation steps. Yes, definitely GenAI plays a very big role, and it takes care of the security aspect. Yeah.
Okay, I'm sort of going through. Okay, this is just.
I have my colleague also, Takai. If you want to pitch in, please pitch in as well. Yeah.
Okay.
Oh yeah, so I like the question about the how to capture and route the data question from Uday. So just to elaborate a little bit more on that, what you said, Anbu. So I think in addition to what you said, I think there are 2 keywords here: data platform and MLOps, right? So you would need absolutely to have an expansive level of observability across a multitude of data sources if you are indeed attempting to build a GPT-like model, a large language model of a kind. So you would need to be able to allow the model to learn from massive amounts of data to generate the level of insights and the level of generalization that we see in these interesting LLM use cases, right? So, and that needs data pipes, it needs data to move around efficiently, right? But you also need MLOps. I think and this is the kind of the standard recommended approach part of the question. I mean, there are established ways, of course, of how to build a machine learning infrastructure, how to ensure that you are collecting the right amount of data, the right size of the data, the right features of the data, right, that the model needs. So yeah, I would also add a data platform and MLOps as two key ingredients to do this.
Yeah, definitely.
Yeah.
Definitely. But we cannot overemphasize the basics, which is like whatever you're doing in your predictive AI, have this data platform extend to this LLM ops from ML ops, right? So another thing, Takai, on the same lines, there's also the question, Monica, that we constantly get, the difference between ML ops and LLM ops. So it's just the same. If you look at ML ops, they talk to the data scientists, talk to the making sure that the model is fine-tuned. They take care of the model by feeding the clean data. They cleanse the data because garbage in, garbage out. So they talk to the DevOps team. They deploy the ML models. That's ML ops. In most cases, the telco engineers, the subject matter experts, let's say radio expert, transport expert, they also play a big role in ML ops because they bring the domain expertise and then explain to these software engineer or even the data scientists, explaining that, hey, this is how probably this would have happened and we need to address our model for this scenario. But LLM ops is, again, you have these similar to ML ops, you have these prompt engineers, etc., on top of it. So which is nothing but your traditional ML ops, but with additional prompt engineering. Yeah.
Absolutely. We have a follow-up on this question, and I don't know whether you, Anbu, or Taka wants to answer to that. Is the question from Uday is, has anyone attempted to do this as you said, create a context using logs and event to create appropriate engineered prompts?
Well, there are attempts that are, as we speak, happening, and this is a reality where RagOps that I mentioned, that is helping in once you have a custom model, then you can have these prompts, then you can get the answers or the responses there. So it is happening, and yeah, it is going to be a reality very soon.
Absolutely. Maybe just we can spend the last couple of minutes we have to kind of try to sum it up, because again, you give us so much information, and let's try to distill it a bit. So you talk about reality and concerns. Where do you feel we are in terms of how careful should we be? So what is your advice to operators that are trying to to figure out what is it they should be doing? Should they be moving forward very aggressively, or should they be saying, well, let's just hold it for now until things settle a bit?
Yeah. So good question, very a good question, and this is there in all the minds of the folks who are from the network, right? So there are two things here. One, automate ruthlessly. Whatever process, we have to question. If from the network, we have to start questioning, can I automate it? Can this system take care of itself? How can I bring the closed loop? So that question needs to be there. They have to ruthlessly automate almost all the function. That's where you achieve autonomy. However, all said and done, the foundations, right? The ML ops to be in place. Where do you collect the data? How frequently do you collect the data? Do you have silos of data repositories? I'm talking about data repositories, data lakes, right? So unfortunately, there are some operators where we were interacting with as well. They have islands of data repository. It's not even, in one place. So imagine bringing all those in one 1 dB for the context, multi-domain correlation. So you have to focus on having these data, the infrastructure, then do a very good ML ops, prepare yourself for the RAG ops, LLM ops, etc. So that's how you should be known. Yeah.
Absolutely. We are unfortunately at the top of the hour, and we all need to move on with our lives, but it would be great to be talking to you for another few hours because there is so much that you can share from your experience. This has been a great presentation. So Anbu, thank you so much, and thank you also for helping us in the background. And Kendra, it's over to you.
Okay, great. Thank you. So that will conclude our webinar for today. Thank you to Anbu and Taki for the very informative presentation. A recording will be made available at sensafili.com in the coming days. Thanks again for joining us today, and we look forward to seeing you at future events.